be a lot of material that I or any of us will probably retain very much, but this is a good book that can help you through it. God's Crime Scene, if you're looking for materials to help supplement what we're talking about in here, and I'm going to take some examples from this book here in a minute too. But before we do that, of course, the 5 facts scholars agree on. Give them to me real quick. 1.
Jesus is a real man.
Jesus existed. Okay. 2.
Real person.
Jesus, so real person, yeah. Existed, real person, same thing. Yeah, it's okay, it works. Second one. He was crucified. What else we got? No body was ever produced.
Lives were changed.
The disciples believed they saw Jesus after his death, right? This is scholarly agreed upon because obviously nobody ever changed their story. And the first century followers' lives were changed for sure, right? So we spent the last probably 3 weeks or so that we had class talking about what? You guys remember? Can we believe the Gospels are true, right? Were the Gospel writers in fact there? And we spent a lot of time talking about whether we could verify those things, whether they were accurate, the writings that we have today, whether they were timely, were they actually written in the first century, and then finally, were they biased? Did they have a reason to lie in 80, in 40, in 80 AD, in nearly 100 AD? Was there a reason for them to lie? Was there anything to gain by the stories that they shared in that time frame? Right? When we looked at the totality of the circumstance, each one of these little pictures represents one other thing that probably represents even a multitude of other things right there. When you consider the totality of the circumstance, we decided or agreed upon when we have enough substantial evidence to suggest that the gospel eyewitnesses are reliable, that they are in fact written by who they say they were written by, and they were written in fact when we say they were written. Okay? Today we're going to talk about the standard cosmological model. Does anybody know what the standard cosmological model is? The science community as a whole, not as a whole, in general, will say that the cosmos was created how?
Big Bang.
It's the Big Bang Theory, right? So the Big Bang Theory, when we hear that phrase, it conjures up a lot of things that are completely unassociated with the Big Bang Theory. Oftentimes we'll consider the Big Bang Theory as part of evolutionary theory or Darwinism. It is not. It is absolutely not part of that theory. That's a completely different thing that's not set upon that. Right, so when we talk about the Big Bang Theory, we're talking about how was the universe created? Did it happen slowly? Was the universe infinite? Or was there a point where something massive happened that created the universe as we know it today? I, of course, believe that. I think the Bible tells us that. We know that God is infinite, and we're going to talk about those things today, but we're going to look at the things that say the universe had a beginning, and that beginning was a Big Bang, and the Big Banger here in question was God. Right, so completely different from the other stuff. There are 2 other things to keep in mind when we talk about the Big Bang Theory, and that's ancient Earth theory and new Earth theory. Right, some people will say and believe that the universe is 4,000 to 6,000 years old. Some people will say the universe is billions of years old. Okay, I don't care which one of you guys think. Right? It doesn't matter, right? Because both are still applicable to God's creation. God can just as easily create a universe that has the appearance, which our universe does, of being billions of years old. God has the power and the infinite miraculous ability to fast forward time, right? So we could be sitting in a 6,000-year-old universe, right? We could also be sitting in a billion-year-old universe based on how God's timeline works. I don't know. I'm not an expert at that. I don't know that any of us are either. Whichever way you feel, if you feel strongly about how you feel, great, good for you. If you don't, then it's probably immaterial because it still goes back to, was the universe created by a creator? Yes, it was. Who was that creator? God was the creator. How do we get to here in natural life? So that's what we're going to be talking about today. Give you guys a peek last week, or 3 weeks ago, I guess, right? The time has a beginning, right? If you never start, you never get to the finish line. The origin of the universe must exist outside of time, space, and matter, and the fine-tuning of the universe is beyond coincidence. So what we're saying here today is that the biblical belief and understanding of God's creation of the universe is consistent with the standard cosmological model, and that is the Big Bang Theory. Okay? So we looked at some passages, right, that even gave a little glimpse, obviously, out of time, out of context. It is I who made the earth and created the man upon it. I stretched out the heavens with my hands, and I ordained all their hosts. We're going to talk about that stretch today. Okay? Who alone stretches out the heavens and tramples down the waves of the sea? We're going to talk about the stretching of the heavens today. We're even going to talk a little bit about the moon and how it tramples the waves of the sea, so how that happens. It is he who made the earth by his power, who established the world by his wisdom, And by his understanding, he has, yet again, stretched out the heavens. So we see that reference of stretching out the heavens multiple times in the Old Testament. Did the writers then understand the expansion of the universe? Absolutely not. Right? No way to understand that. No way to know that. Stretching, when you look at the sky, is it broad? Is it stretched? Absolutely. So there's some context there. But still, it's interesting that the biblical references would use the word stretch because of what we're going to look at today. It's also subject to the second law of thermodynamics, and we're going to get to that, but we'll get to that when we get to it. So did the universe have a beginning? That's one question you have to ask when we talk about the creation of the cosmos. Or is the universe infinite? Could it possibly go back forever? Well, what three things do we have to have a universe? We talk about them in here all the time. Time, space, and matter, right? And so some of the prevailing theories say the universe was created by the particles flying out in space over time that eventually created the things that started the initial Big Bang theory. Well, unfortunately, that theory, which is pretty prevalent among those that are trying to explain this first unknown cause, doesn't explain itself, right? It doesn't explain how you get time, space, and matter from time, space, and matter. You still have to rewind the clock. Well, how did that time, space, and matter get there? Right? It doesn't account for the multiverse theory. So if you're a comic books and movie fan and now you're watching all this Marvel stuff, there's a lot of stuff about the multiverse, right? All different branches, and if you're watching these, like the Loki's the new show, and right, all these branches of reality and stuff and all these universes, talks about there being different multiple universes and that there's a machine somewhere. This is a real scientific theory, guys. This is why we have to separate scientific theory from science. Right, and from scientific fact, because they are very different things. There's a scientific theory that says there's a machine out there somewhere that's cranking out multiverses. It's cranking out different universes. And what that doesn't account for is what? The time, space, and matter associated with that universe machine. All right, so it's kind of weird that would be an actual theory that still doesn't explain itself. All right, so a couple things we want to look at. Did the universe have a beginning? So first of all, the impossibility of infinite regress. And I'm talking way above myself. A lot of you guys are going to understand what I'm saying. I don't most of the time. Okay, but doing this research, infinite regress means infinity is a number you guys are all familiar with. You guys know the symbol for infinity, right? It's kind of that sideways 8, right? And they say that that's infinity. And what does infinity mean? It means forever. You're exactly right. It means it goes on forever. Could the universe have possibly gone on forever? Well, it's like a race, and we're going to talk about that because that's what we associate time with, is how do you get to today if you don't have a starting point? And before, whenever I gave this example, I actually had somebody line up at the back of the room, and we were going to run, see how far it would take them to run across the room, or how long it would take them to run across the room. But before I hit start every time, I'd ask them to move back 6 feet, or 6 inches. Now move back 6 more inches. Now move back 6 more. If you never have a starting point, you can never get to the current point, right? So it's just this is a philosophy, right? This is a philosophical question. This isn't a factual question or a biological question. It's a philosophical question. It's can you get to this point in time without having a starting point in time? I would suggest no, that you cannot. Einstein and Friedman both predicted an expanding universe in the 1910s and the 1920s. So Einstein is popular or well known for his theory of what? Relativity. And a lot of that theory of relativity is based on the idea that the universe is expanding. A lot of scientists came along after him and looked at the universe and looked at different particles in it. We're going to see those here again in a second, and saw that the universe is indeed expanding. And so something is expanding. What do you have to have? You have to have a beginning, right? So this ties the philosophical into the metaphysical portion of it, right? And so now we've got spectrograph readings. Again, I'm sorry for all the scientific stuff. It's not my thing. But a spectrograph reads colors as you look at it. Does anybody know how a spectrograph works? Oh, good, I can fake my way through it. Okay, so you can look at it in the universe and see the different colors that are emanating through space and time. And what they've discovered through objects that they know are moving away from the Earth, right, is that they emit a red glow. And objects that are moving towards the Earth emit a blue glow. And I don't know why. Okay, I'm not, again, not my thing. But it is widely understood that that's the case. And as they look out at the different universes and the different galaxies, they're all in red. They're all moving away from us and from each other, right? And so if that's happening, again, it's like the race that we talked about at one point. In order to move away, you got to pull them back. And so at some point, there's this initial beginning. right? You can't infinitely regress an expansion and not have a beginning point, right? And so it doesn't work that way. So at one point they had to be closer, okay? Another thing, the second law of thermodynamics, the quantity of energy in a system like the universe remains the same, although the usable amount deteriorates gradually over time. The example that this book uses is like a wind-up car. You guys remember the wind-up cars when you were a kid? All right, so if you walked into a room and you saw a wind-up car moving around, what would you assume? I think you could assume a couple of things. You can see the wind, you know the sound, it'll stop eventually, and somebody had to wind it up, right? So if you're familiar with the concept of a wind-up car, you know that eventually that energy is going to disperse within itself and stop moving around, right? The twist.
The way I look at the scientific channel, and what they were saying is, the universe is kind of like the Big Bang Theory. If you hit a baseball, it eventually goes up, and then it's going to come down. So all those particles you saw earlier on that first slide, all the particles exploding out, gravity is going to bring, eventually, because our universe is still expanding, it's eventually going to regress, and gravity is going to take hold, and
it's going to stop moving.
It's going to stop moving.
It's going to stop moving. We're all headed towards a slow heat death.
Right.
Because of that. Because whenever everything stops moving, that energy redistributes, right? Because the amount of energy doesn't change. It's how much you can use. So eventually, we're all headed towards this heat death. It's like the law of degradation, right? We're all born and we all come out of the womb and we're all excited for life and we grow, but at some point, we're all headed towards a what? The moment you're born, you're headed towards death. You're not headed towards getting better, right? You may physically be better, you may be more capable as an earthling, but you are degenerating the rest of your life in some form or fashion, right? So if this universe is wound to the point it's moving, eventually it'll stop moving. And if that's the case, it can't be infinite, because again, it has to have a starting point. Helium. Who thought we'd be talking about helium today? Helium is the second most abundant element in the universe, or univaries, according to this slide, but requires nuclear fissions and ridiculously high temperatures and dense conditions. That's exactly what a Big Bang would look like. So the second most prevalent thing in the universe is helium. Helium only is created by this mass, this dense thing with huge amounts of energy. And there's nothing in the universe that does that today. It had to have come from some bigger event, some more dense event. That dense event being all that stuff that's pushed out where it started. That's when it's most dense. And the explosion or the fusion, obviously the creation or the expansion or the ultimate Big Bang that we've talked about. And then finally, cosmic background radiation. It testifies to an extreme initial environment of which we've moved on from. Right? So scientists can still see radiation emanating from a bigger event from the beginning of the universe. That's why generally scientists will tell you and agree that the universe does have a beginning. Right? And so it's from that point we start to disagree on how that beginning happened. And that's where you see so many of these theories, because a scientist or somebody with one of these theories will look at you point blank and say, well, there's a machine out there that's creating these universes. And you're like, oh, he's a scientist. He must know stuff, right? That's generally what we do, right? We do that with our doctor, right? We do that with science. We do that with scientists. And so we have to make sure that we're aware of the differences between actual science, scientific theory, and actual rationality, right? We can use our own rationality and say, is that a theory, or is that something that you have something to back that up with?
But machines don't make themselves.
That's exactly the point between the multiverse theory, right? And when you talk about the space-time and matter theory that eventually it creates space-time and matter, well, what about space-time and matter? Who created the first particles, right? And so it's a question of origination, and where science is trying to figure out that first uncaused cause.
Well, Travis, now scientists are saying it's a continuum theory that has always existed. Nothing created the earth, but it always existed. Mm-hmm. That's the new theory that's out right now.
It is, and that's exactly why we're having this conversation. These are 6 things, at least, out of probably dozens that point to a creation. Right? You wouldn't have expansion without initiation. You wouldn't have cosmic radiation from an event that's no longer here if it didn't happen, right? You wouldn't have helium if there wasn't an event that was so strong and powerful that it created this helium out in the universe. So you've got all of these different things that load up that make you come to the conclusion scientifically that the universe does have a beginning. And so we get there through that. So the universe had a beginning. We have evidential variety, right? This isn't just one thing. And we've talked about that in here before. Are there enough different varieties of evidence that we can say, okay, when we have all of these things, they eventually point to the same thing? Talked about philosophical evidence, that starting line and where you get to, right? Theoretical evidence, that's Einstein. The residual evidence of the radiation out there. Observational evidence, we can see through the red and blue spectrums that stuff is moving away. Right, and then we've got the thermal evidence, and that's the wound up, right? So we've got enough in the quantitative, that's from the helium. So there was an event that accelerated the expansion of the universe. So if we get to there was a beginning, what could cause the universe, right? Well, it must be outside the room. And that's what this book focuses on, is outside the room, because it's written by the same J. Warner Wallace that does the cold case Christianity, and he still relates it back to a lot of his crime-solving days. He says when you go into a room and you look at the evidence, when you've got a death, right, it's either accidental, it's either natural, or it's something else that's outside of those two things. And is there enough evidence inside the room to say, okay, yes, all this happened naturally, or do we need to figure out something that's not here that was the cause of it? And that's what we're looking at when we look at the cause of the universe, is it's got to be outside time, space, and matter, because we know that because there was that initiating event. So it must be an uncaused cause, or we still have an origination problem, right? So whenever somebody has an answer for the universe's creation, well, what was the cause of that? What was the cause of that? Thomas, you nailed it when you said with the multiverse machine. Well, who created the machine? That's the question. Where did the machine come from? Where did the matter necessary for the machine come from? Right? That's where we look to God and say God was an uncaused cause. God is almighty. God is in existence. God is infinity in a world where our natural bounds don't really account for infinity. Right? They don't. And so it must be either personal or impersonal, an agent or an event. Right? It's either something or someone that created this, and they did it with purpose. And that's where we start looking at some of this other evidence and go, it sure looks personal to me. It's so fine-tuned, and that's what we're going to hit next, is the universe is fine-tuned for life. We're going to look at foundational evidence, we're going to look at regional evidence, and then we're going to look at locational evidence. So 3 different forms of evidence that say our universe is so fine-tuned, and this is where we could spend weeks, guys. We could spend weeks looking at the intricacies of the moon and its alignment. Right? We could talk about so many different things that if it was any different, the ability for carbon-based life forms to exist. Right? It's not that we would be different and maybe we'd have 3 arms if the moon was a little different, right? It's could carbon-based life form even exist if any of these parameters were different? Okay, and this is just crazy to see all this stuff, right? When we look at the constants and the proportions of the nuclear force, let's see, where is it? Okay, so these are my notes for the next slide. You have to forgive me, I'm making sure I'm at the right spot. I am. Okay, so the foundational fine-tuning. These are the building blocks of the universe. When we talk about atoms, when we talk about electromagnetic force behind the atoms, listen to a couple of these. And this is where I'm actually going to need some of those dimes. So the constants and proportions of the strong nuclear force, weak nuclear force, electromagnetic force, and the force of gravity. Did anybody understand what I just said? Okay, I don't either. So I'm going to be perfectly transparent. My kids are like, yeah, we get it. Because they're doing science, so they understand. These things, right? Nuclear force, these are all within the atoms. Electromagnetic force, the force of gravity, must exist within a very narrow range for life to exist. 1 in 10 to the 40th power. So 1 in 10 to the 40th power. I don't think I have enough board to write what that looks like. Okay? Everything in our universe relies on gravity. It is often referred to as an unexplained miracle. That's really convenient science, right? But everything relies on gravity. When you look around, everything from the atomic level to the cosmic level is often referred to as an unexplained miracle. If the expansion rate of the universe deviated by more than 1 in 10 to the 37th, 10 to the 37th, so better odds here, I'll grant you that, okay? Or the mass density of the universe, so the mass density, varied more than 1 in 10 to the 59th. Okay, so now we're going the other way. 59, I don't know what I'm doing here. There wouldn't be a single habitable galaxy or planet in the universe. The creation of chemicals are favorable to life. Life requires carbon, oxygen, and other secondary elements formed in stars, but the process of stars converting hydrogen and helium to carbon is so fine-tuned that life wouldn't be possible with that fine-tuning. So who's got some dimes for me? Got a couple dimes? Okay. It's a good start. This is how you tip your teachers. Appreciate that. Look at that. We're making some universe now. Okay. All right, you see these dimes? Let's see how many I've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 dimes. It's almost a coffee at camp, girls. You're welcome. Okay, so we've got 17 dimes here. I'm going to stack them up. In fact, I'm going to stack them on this white paper so you guys can see them a bit better. You see that?
I can't see.
Can everybody see that?
No.
You can't see that.
No, there's a chair.
That better? Okay. You guys see that stack of dimes? Imagine covering the North American continent. What's the North American continent? How does that stretch? Canada, U.S., Mexico. Okay. Cover it in dimes and stacking them until they reach the moon. Okay? So instead of a stack of 17 here, I can spread them out. So now I've got 17 piles. It's not covering very much, right? I'm going to stack them up to the moon. I'm going to cover the North American continent. I'm going to do it 1 billion more times. Okay? And I'm going to blindfold one of you and ask you guys to find the dime that I put a mark on. It could be anywhere. The odds of you finding it, that's 1 in 10 to the 37th power. The same level of precision required in the strong nuclear force and the expansion rate of the universe to sustain life. It's pretty fine-tuned. That's a big old coincidence. Good thing it's the only coincidence, right? Okay, now imagine stretching a measuring tape. Okay, so we're going to take a measuring tape, but instead of it being this board, each one of these marks represents an inch, give or take, okay? But instead of this board, it stretches across the entire known universe. So that's a long measuring tape, okay? Universe, not galaxy. Galaxy would be way easier. We're talking about the universe. Okay, now imagine one particular mark on the tape represents the correct degree of gravitational force required to create the universe we have. If this mark were moved more than an inch from its location, right? That's the amount of change across the universe that we would need. The altered gravitational force would prevent our universe from even coming into existence. Right? It couldn't form if there was that much change. Imagine trying to fire a bullet to a 1-inch target on the other side of the observational universe. The accuracy required to accomplish such a feat has been calculated at 1 in 10 to the 60th power. Compare this to the precision required in calculating the mass density of the universe. Okay? So I'm losing you, I'm losing me. Just talking about these examples, right? Imagine comparing the universe to an aircraft carrier like the Stennis, the USS Stennis, which is 1,000 feet long and 100,000 tons. If this carrier were as fine-tuned as the mass density of our universe, subtracting 1/1000th of a trillionth of the mass of an electron from the total mass of the aircraft carrier would sink the ship. Right? This is how fine-tuned everything in our universe is, from gravitational pull. Thomas, do you mind grabbing that door for us? Thank you. Everything from gravitational pull to the expansion of the universe. A lot of fine tuning. So that's the foundation, right? Science, in many cases, will call these happy cosmic accidents. Well, it's a very, very, very specific cosmic accident that's repeatable across multitudes of different scenarios, not just one single scenario. Okay, so the regional fine-tuning, the galaxy. So we went from the foundation to building blocks and gravity to the foundation of the universe, right? So the shape of the Milky Way is favorable to life. It's elegant, it's spiral. Do you guys know the Milky Way was spiral in shape? So kind of spiral, like the spaghetti that's kind of spiral, right? Where most of the galaxies are elliptical or irregular. If we were bigger, and irregular, the nucleus would release destructive radiation and matter. So there'd be radiation and we'd be fried. You couldn't have carbon life. Spiral form encourages stars to form before they are threatened by heavy elements. So it encourages the stars to form. The position is just right. There's no gravitational pull where we exist from other galaxies. Remember, gravitational pull is one of the strongest elements or strongest forces in the galaxy. None of the other galaxies are pulling us. If they were, we'd be in trouble, right? The size of the Milky Way is perfect for life. It's large and sparse enough to prevent gravitational pull and collisions with other star systems. So now we're talking about gravitational pull of other galaxies, and small and dense enough to allow gas formation from gas infusion. Again, I'm losing myself, so it's not just you. The solar system, positioning of the sun is favorable to life. Our sun's location protects us from the core radiation at the center of the Milky Way. If we were further, there wouldn't be enough heavy elements to even for the planets to have formed. If we were closer, the radiation would be too severe and the gravitational influence of the stars would be too strong. We'd be sucked up by other stars. The composition of the sun provides just the right hydrogen to form planets and heavy metals necessary without over-radiating or poisoning our planet. Color, it's not too red or blue. Our sun is just right to allow for photosynthesis. So photosynthesis couldn't happen with a red star or blue star. Also, a single star eliminates the multi-star gravitational forces. It also helps with tide cycles and prevents us from overheating. But the age and mass of the sun, sorry guys, it's just a lot of stuff. If older or younger, the luminosity would be unstable. If it was larger, it would burn too rapidly and too erratically. And if it was less massive, gravitational problems would exist. So if you just look at the exact placement of the sun or in our universe where we're at, we could talk about this one for hours. Different things that would change if we weren't exactly how we were. In relationship to other planets, this one's interesting to me. Large gas giants protect Earth from hazardous cosmic materials. You guys know who the biggest gas planet is?
Jupiter.
It's Jupiter, right? It cleans out the solar system. Its incredible gravitational field redirects asteroids and cosmic debris. All these other planets that are out there, they're just part of that circle. They're helping us stay safe. We know the moon even does the same thing to a certain degree. And finally, locational fine-tuning, right? When we talk about Earth, Earth's position to the sun, its microscopically correct habitable zone. If only slightly closer or further, a stable water cycle would be impossible. What's our water cycle? What happens? Yeah, so the water from the ground evaporates, moves up to the clouds. Clouds get heavy, they drop it down, right? Closer or further, that wouldn't happen. All right, if that wouldn't happen, we'd have a lot of problems.
Okay.
Right? We'd be in the water world, right? Tiny changes in the orbital tilt or variations of the tilt would eliminate our client completely. If Earth rotated slower, our days would be too hot. That was interesting to me. If we rotated slower, the sun would bear down on us with such certainty that we would burn. And if it did it slower, then on the other side of that long day would be uninhabitable cold night, right? Yeah, and we would not have survived. Yeah, we can survive today. We've lived through an ice storm. We could handle it, right? Your ancestors couldn't have, right? 200 years ago, they couldn't have, right? The heat or we live in Houston. It's pretty hot. But imagine it being much, much hotter for much longer periods of time. And if it went slower, the wind speeds would be too extreme. So just the change in temperature, if it was going slower, if it was shorter, so if it means it was going faster, the wind speeds would be too extreme. So the Earth's atmospheric conditions, gravity, when we talk about our own gravity, If it was stronger, we'd have too much methane and ammonia. Our gravity allows methane and ammonia to float up. Right? If it was heavier, that would all be sitting around here. You guys ever tried to breathe in methane? I wouldn't recommend it. Or ammonia. Does ammonia get a good rap? No, it doesn't. There's a reason for that. So that's all in the air, but it's going up. If it was weaker, we wouldn't be able to retain water. Right? The water would just keep going. It'd go up to the clouds and nothing would pull it down because you wouldn't have the heaviness in the clouds that causes the rain. Oxygen to nitrogen is just perfect, as if carbon dioxide and even water vapor, vapor levels providing rainfall. So just again, minute things that are all just exactly perfect for us. Earth's terrestrial nature. Our crust is perfect. If it was thicker, oxygen levels would be impacted. If it was thinner, it would result in too much volcanic activity. Right? We'd be all running around from our own Vesuvius here, right? Nutrient and mineral concentrations required for carbon life vegetation is perfect, right? It's also improbable that it would all be that perfect. Earth's relationship to the moon. The moon is critical for our existence. It stabilizes our orbit and our rotation. Without the moon, our axis would wobble dramatically. Right? I just like to be on a wobbly Earth. Right? I don't like to be in a wobbly car. Maybe as much as 90 degrees. Can you imagine our axis shifting 90 degrees? Without the moon, that would be a big problem. And the moon also provides even more than we can imagine, including directing tides, which helps with birds, it helps with whales, it helps with, the moon also provided light to our ancestors, right? Also animals, other nocturnal animals, and it also gave us a measure of time, right? So the moon is obviously very important to our existence. So our cosmological conclusions, and I'm running over a bit, the universe had a beginning, the origin was an uncaused cause, the origin was outside time, space, and matter, and the universe is fine-tuned for life, foundationally, regionally, and locally. The universe was created by a Big Bang, and our conclusion is that God was the source of that Big Bang, and that it is indeed personal and not an event. And so we look at Romans 1:18, and you mentioned this, a little bit of this earlier, right? Against all ungodliness and unrighteousness of man, who suppresses the truth in unrighteousness, because of what may be known of God is manifest in them, for God has shown it to them. This verse gives you a whole new perspective when you look at it from an apologetic standpoint, and you look at what the modern media or the modern scientific theory community. And notice I'm saying scientific theory community, not scientific community. When you look at that community, they say that this isn't possible. Well, I tell you what, the evidence sure suggests otherwise to me. It says, for God has shown it to them, and God continues to show it to us in our discovery of the universe. I mean, before 1910, we had no idea of the theory of a universe expanding before Einstein, right? Before the 1940s, we did not have the spectrometer where we could tell if the universe was moving away from us or towards us, right? And we continue to see that. And there are things every day that come out that probably in scientific circles would lend even more credibility to the theory. It says, for since the creation of the world, his invisible attributes are clearly seen, being understood by the things that are made, even his eternal power and Godhead, so that they are without excuse, because although they knew God, they did not glorify him as God, nor were they thankful, but became futile in their thoughts, and their foolish hearts were darkened. That's exactly what we and what our kids are going to be going through whenever we talk about the origin of the cosmos. Right? When we talk about whether or not there truly is a God. And we see this, and we saw this called out even before the writers understood anything about cosmology. Right? So next week, we're going to hit the origin of life. So we're going to go from the expanding and the ever-present universe, which is unknowable,